So here we are building store analytics solution using AWS, Yugabyte and Grafana. So the way this works is we have a generator which mimics store transactions, right? So it sends the dummy store transactions and we will be using 200 transactions per second. These are then captured by the source Kinesis data stream, right? So this is the one that you see over here. Now at this point, we take two actions. One is there are new transactions that are coming in. We store them as raw transaction into the Yugabyte database. Now Yugabyte database is an interesting database in a sense that it supports both NoSQL and SQL on a same cluster, right? So on a NoSQL side, we have a Cassandra compatible DB, or you can say Cassandra compatible API. And on the SQL side, we have a Postgres compatible API. Okay. Now to store the raw data, we are using uh, the YSQL. Okay, the Cassandra NoSQL table. Now the second action we take at this point is we send the data to Kinesis Analytics. Now Kinesis Analytics has two types, right? One is a SQL based, another is a Flink based. Now SQL is a legacy one. We are utilizing the Flink based Kinesis Analytics application here, right? So this will then summarize the transactions which are coming in and then sends it to another data stream, which let's call it sync. Okay. Once the data arrives in the sync stream, it is picked up by another Lambda function and is sent to Yugabyte again, right? So it is the same instance of Yugabyte, but now this time the data goes into the SQL table, right, which is Postgres compatible API. Now, why we are using Postgres compatible or a SQL side? Because it is easy to do the dashboarding and any querying that we need to do with SQL, right, rather than with the SQL API. Once the data arrives in here, we have a Grafana dashboard built on top of the summary data, right? So you can have a summary as to how much is the total sale, what is the total sale into each store, what are the top products, top selling products, what are the laggard products, right? The products which are not selling very well. Another couple of things here you can see is that the database authentication, right? The parameters for user ID, password, host, and everything is stored in the parameter store, and Lambda picks up those credentials from parameter store on AWS. Similarly, another thing that we need in this solution is the schema, the AWS glue to hold our schema for the streams. Let's see the working of this solution now. All right, so I'm using Cloud Shell to work with the Yugabyte database. Right? So this on the left side you see a SQL SQL SH connected. Right? So I'm connected to the NoSQL side, and this right side is the SQL. Okay. Right, so this table is empty, and if we check the summary table, right, so that's empty. So we'll go ahead and start the generator. Right. So what we'll do is we'll send 200 records a second. Now this 2 means 5. So every 5 millisecond it will send a data, send a record, right? So that means per second we are going to send 200 records. All right. So what you see here is that it is starting to send data across 7 stores, right? So we have generated 7 stores, and there are 50 records for the products, right? Now the way it will work is it will start sending random transaction records across these stores and products. Okay, so let's go quickly and look at what's happening on the SQL side, right? So we already have 2,289 records, right? It is sending data for quite some time now, for 10 seconds. So that means in a minute we should have 12,000 records. Okay, and since the analytics is happening every 30 seconds, we should see data in some time. All right, right. So data had started to come in. Now, when this summary is being collected, right? So the Kinesis is data is being sent, and as well as the summary has started coming. We can go ahead and look at our dashboard. All right. Okay, so now let's look at the Grafana dashboard that we are creating. So what we have here is a total sale across all the stores, right? So this is $24.7 million is the sale across all the stores. Here you see all the 7 stores, 1, 2, 3, 4, 5, 6, 7 stores from which the data is coming in, right? Which for which the data is available to us, and it tells you for each store how much is the sale for that store, right? So for example, if you see a 28.7 here, what is the contribution of that store in that, right? So this is that individual stores. Now here we see that this is for the store one, what are the top selling products and what are the not so well selling products for store one, right? So awesome, soft tuna or sleek, right? These are the ones which are not selling very well. And you can actually look at the store number 6318. So if let's say if we want to look at some other, let's say 8, and you see that for 8, what is the data? Is the right? These are the top selling products for store number 8, and these are the not so well doing products for store number 8, right? So you can look at for the different stores, what are the analytics, um, what is the individual stores contribution, what is the total sale across all of the stores. Now another interesting point you can see here is if you see this graph here, right? So let's now this graph is based on 5 minutes window. Okay, so that's what I've set here for 5 minutes window. So that means since we are doing analytics every 30 seconds, I should see 10 points, right? 1, 2, 3, 4, 5, 6, 7, 8. 2 are missing. The point is we are running almost a minute late, right? From the real time. Sometime you will see 9, sometime you will see 8, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, right? You will not. So, but this is as real time as you can get. The reason is, so 30 second is our window. 10 second is the delay allowed, right? So 40 seconds uh, is the minimum delay we will have on the on the data, right? On the summary data. So so this is doing, you this is as good as, as close as you can be to a real time with this solution.